Hello and good morning, CTS265 section 840 students for the fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and what we're going to be doing here is I realized when I wrapped up the lab 1-1 video that we had talked about split horizon, but I had not gone back to poison reverse, and I actually want to focus some time because this is a question that a lot of learners have is, what is split horizon? What is poison reverse? Do I have to run both of them? Why would I want to run one as opposed to the other? And are they mutually exclusive or are they inextricably linked? And so we're going to do a deep dive here and take a look at some debug output and have a discussion on poison reverse and split horizon. So as you can see here, I have up in the front of my screen, I've got the RFC 2080, which is the RIPng RFC. And one of the key points to take a look at here is it says right here in this sentence, it says split horizon with poison reverse. And it says more simply poison reverse. And what this means is that when we're using poison reverse, or you'll hear it referred to as split horizon with poison reverse, because by default, and specifically in the Cisco implementation, split horizon is on by default. So if we do nothing else except type in our IPv6 router RIP name process to create the RIPng process, split horizon is going to be on. Now, there's an option where we can turn on poison reverse with split horizon. However, when you do that, and we're going to see this here in some debug output, what's happening is only poison reverse at that point is working. So poison reverse takes precedence over split horizon, and again, this is in the Cisco implementation. And it's key to remember that the RFCs are the standards. However, individual implementations can vary from vendor to vendor. All right, and so it's interesting here. It says it does not include any routes in its updates, but sets their metrics to infinity. And infinity in our case with RIPng is 16. So in effect, advertising the fact that there are routes that are not reachable. It says this is the preferred method of operation. However, implementation should provide a per interface control, allowing no horizoning, split horizoning, and poison reverse to be selected. Now, this reference here, where it says for a theoretical discussion of split horizon and poison reverse, I highly recommend checking this out. This is a link here that'll take you to the bottom of this document, and it'll reference RFC 1080 or 1058, sorry. RFC 1058, which is the RFC for RIP. And if you were to look into section 221, you would see that they have a conversation here on split horizon. And this is some really good information about how, when, this dates back to 1988, as you can see. And it's a conversation of back in 1988 when they were writing the RFC for RIP, they were having the discussion of what is split horizon, what is poison reverse, and theoretically how those would function. So again, RFC 1058, section 221, I would definitely take a look at that. And then fast forward here to 1997, so about 10 years later with RIPng, section 2.6 in the RFC 2080, there's a section here, split horizon, clearly shorter than the original discussion, but definitely good to read. And again, this is interesting how they phrase this here, split horizon with poison reverse, more simply poison reverse. And so let's go ahead and dive in and take a look at this. We're going to demonstrate both of these. And this is our topology over here to the right. All of this is set up already. It's literally, I haven't changed the config from our first conversation. And we're going to first take a look at split horizon. We're going to look at how to validate that we are running split horizon without poison reverse. Then we're going to turn poison reverse on. And we're going to take a look at what happens, what the differences are between the two. And we're going to prove that in the Cisco implementation, when you're running poison reverse, that in fact, bring back the RFC, this sentence right here, more simply, poison reverse, that when you're running both split horizon and poison reverse, really you're only running poison reverse. That both of them are not functioning, right? That only the poison reverse, shouldn't say that they're not functioning, but what I should say is poison reverse is going to take precedence. So let's dive in and take a look here. So let's get onto the command line. We'll go from user exec to privilege exec, and actually we'll hang out here at privilege exec. So if I say show IPv6 route, and I'm on router 1, we're going to see those same 4 RIP routes that we saw before. We're catching and let me pull this guy up here so we can cross-reference. So we've got the loopback interface on router 2, which is simulating the gigabit 00 interface from the actual lab. We've got the 3 loopback addresses, loopback 10, 11, and 12, and we're learning all of those, and that's great. So if I say show IPv6 RIP, this is going to tell me what my RIP settings are. So you can see right here, and these are all default settings. We've got updates every 30 seconds, and again, remember with RIPng, our updates are automatic. So every 30 seconds, I'm getting the entire RIPng routing table. It's being sent and received. We've got our expiration. We took a look at this. Remember that if a route is removed, it's going to sit in the routing table for 3 minutes or 180 seconds before it gets removed out of the routing table. Once it's removed from the routing table, our garbage collector is going to kick in, and it's going to sit in the RIP database, right? Show IPv6 RIP database. It's going to sit in there for an additional 120 seconds, okay? Now, here's what we're interested in. Split horizon is on, and poison reverse is off. And this is a common point of confusion for new learners, because the question is, well, why not just have them both on? And we're going to see why. Because when poison reverse is turned on, it's going to take precedence. So Cisco's implementation of RIPng says, okay, we'll start with split horizon, and we're going to leave it up to the user as to whether or not they want to turn poison reverse on. Because again, by default, it is off. So let's clear our screen here. And let's kick in our debug here. So we're going to say debug IPv6 RIP, which is pretty much going to do all of the RIP debugging for us here. And we should be familiar with this output from our first video. So, and there we go. So those are sending. You can see we're sending multicast updates. And this is going out our loopback interface. Because again, the loopback interface is running the RIPng process. And that's one of the interesting things. Remember, with RIPng, there is no passive interface command with RIPng. So I can't simply enable the process on the interface and then passive the interface so it doesn't send the updates out. And again, this is one of the drawbacks of RIPng, especially if you were to start to talk about a larger scale deployment, where every interface on which RIPng is enabled, every single interface is literally every 30 seconds sending out the entire routing table. Now, I think we just saw what I was looking for there. So let me go ahead and say you all for undebug all. And let's scroll back just a skosh here, and received. That is what we're looking for, is what we're receiving. And yes, and then what we're sending. Okay, so in the debug output here, let's take a look at the very top. So it says RIPng, it says response received from FE80::2. Now we know that that's referring to this interface, and again, on router 2. So we received a response, and what the response is, and again, the command in the RIPng header, we've got the command at 2 for the response version 1, not because it's RIP version 1, but because it's the first version of RIPng. We've got the must be 0 is equal to 0. It's again kind of ironic. It must be 0, and yes, it is 0. And then we have the number of route table entries, 5, 1, 2, 3, 4, and 5. Because these are the advertisements we're receiving from router 2. on serial 000 for the RIPng process name CCNP. Now here's what's interesting. So I'm receiving these 5 routes from router 2. When I go to send my update out to loopback 0, how many route table entries am I sending? Well, I'm sending 6. I'm sending the actual loopback address itself, the transit network, and then 1, 2, 3, 4, these 4 routes that I've learned from router 2. Now, contrast that. Now remember, that's going out this loopback interface here. So we have split horizon is on. And what does split horizon say? Well, split horizon says that if I receive an update and I receive routes, or I'm learning routes in through this interface from router 2, that I cannot then turn around and advertise those same routes back out the same interface over to router 2. And we see that right here. And this is what I love about the debug output. So look at my update that goes out serial 000, sourced from my link local address. And if if I said loopback before, I apologize. Up here, it's definitely the link local IPv6 address. And what's my destination? Well, it's the RIPng multicast IPv6 address FF02::9. So let's take a look. What does my update out that interface look like? So out the loopback interface, right? Loopback, what are we? Loopback 0. I send everything I know about, right? Because that is what RIP does. By default, it's going to send everything out, all of its interfaces on which the RIPng process is enabled, with the exception of the split horizon rule, which says that I get this update in. This is coming in from router 2. These are the advertisements from router 2. However, look at what I am sending to router 2. What am I sending? I'm only sending how many route table entries? 2. And now we have to ask ourselves, well, why is that? And it's because of split horizon. Because the 10 loopback, the 11 or the 12 loopback, the 11 loopback, and the 3 loopback address, I'm not going to advertise those back out because of split horizon. And so hopefully this makes sense. And remember, split horizon says that if I receive routes in on an interface, that I am not to advertise those same routes back out that same interface. Now, keep in mind, 1 and 2, right? So why is it advertising 2? And this is a great question. A lot of learners have this question. So, because I just made the statement that, take a look, we're receiving 2 right here, right? And this is being received from router 2. So you're probably asking yourselves, well, wait a second, Travis. You just told me that poison reverse states that if I receive it in on an advertisement, in on a specific interface from a neighboring router, that I can't advertise it back out, but yet here it is being advertised back out. Well, remember, this is going to be all about administrative distance. And in the lab, we saw this, right? Where, excuse me, where in our routing table, and let me go ahead and let's take a look at the routing table here. So I'm going to clear this right now. If you want to screenshot this, definitely screenshot it now. So I'm going to clear this right now. And remember, when we look in our routing table, show IPv6 route, when I look in that routing table, is that transit network a RIP route? It is not. And why not? And it's all about the administrative distance. So here is my administrative distance for what? A directly connected route. And directly connected routes will always have an AD, administrative distance, of 0. And we know that RIP And this is for all RIP versions, RIP 1, RIP v2, and RIPng, the AD is 120. So I get the RIP advertisement in like we saw up here earlier. And let me pull this back here. So the RIP advertisement comes in from router 2. And that's okay because he has RIPng running on this interface. However, I also have RIPng running on my interface, and I'm going to advertise that back because I'm not looking at it as a RIP route I'm learning from router 2 because I'm learning it out of my RIB with a lower administrative distance. And so, as you can see here, Split Horizon is going to basically omit these 4 RIP routes that I have learned and installed into my RIB when I advertise or when I send my advertisement back over to router 2. And so this is Split Horizon, and this is exactly what Split Horizon means. So now, let's go ahead and take the next logical step. Let's go ahead and turn on Poison Reverse. So again, if I say show IPv6 protocols, I'm sorry, show IPv6 RIP, if I do show IPv6 RIP, we can see here, Split Horizon is on, and we proved conclusively it's working, it's doing exactly what it's supposed to do. And Poison Reverse is off. So let's go ahead and go into global config, and if I were to go into interface serial 000 and say IPv6, now I've got a lot of choices here, and RIP is one of those choices. Now router is also another choice. If I say router and do question mark, the only option here is for ISIS, right? And stay with me here for a second because there's a reason I'm doing this. If I say IPv6 RIP, it wants me to identify the process name, which, and I'm drawing a blank here, it's NP, CCNP, and I say CCNP question mark, take a look at the options I have. So we've got the default information option, which we saw in the first Lab 1.1 video. And what is that for? That's if I want to advertise out a default route. I've got the enable command. What is that for? This is for enabling the RIPng process on the interface. I then have the metric offset, and that would be to adjust the metric if I wanted to be like more of a, if I wanted it to have a different metric than what it's being received with. And then we've got the summary address. And again, that's if I want to do summarization. You'll notice there is no option here for Poison Reverse. And now let me roll back to the RFC. And remember, the RFC is I don't want to say it's like a hard and fast, it's not hard and fast rules like you have to do it like this, because as we've seen in previous classes and previous videos, where vendors take the RFC and then they will go ahead and they will implement their interpretation and maybe throw their secret sauce in, right? So where are we at here? Yeah, so this is the preferred method of operation. However, implementation should provide a per interface control, allowing no horizoning, split horizoning, and Poison Reverse to be selected. So do we have per interface control here? I don't see it, right? So how would we deal and manipulate Poison Reverse? Well, if I was to say IPv6 router RIP CCNP and do a question mark from the RIP configuration, you can see that here's our split horizon setting and here is the Poison Reverse setting. So let's see, can we handle it not at the interface level? Whoops, sorry about that. Poison Reverse. So there's no way for me to specifically state or specifically turn Poison Reverse on a selected interface. So what I can't do is say, oh, Poison Reverse, and let's pull our diagram up here. What I can't say is, oh, Poison Reverse, I'm going to Poison Reverse here on serial 000, but I'm not going to do it here, right? Or if I'm router 2, let's say that we were running RIP this direction, right? I can't say, oh, Poison Reverse, we're going to turn it on here, but we're going to leave it off here, right? And so we can see that in the Cisco implementation, you can't do that. All I can do is go into the global RIPng router configuration section, and literally enable poison reverse. Now, for a little richer output, what I'm going to do is we're going to do it on router 2. So let me exit out here, and actually let me end here, back to privilege exec, and let's say debug IPv6 RIP. So we've got our debugs going, and every 30 seconds we're either sending or exchanging information, and that's actually a good point. So the sending and the receiving, it's typically the neighboring routers that kind of tends to sync itself up. So it's not that, you know, I receive the advert like here. So you can see I get a response from router 2 at the very top, right? And typically I don't have to wait 30 more seconds to send something, right? Like the timers aren't completely skewed so that, you know, you're waiting 29 seconds. So they typically tend to be pretty close, as we can see, right? Take a look at what's happening here. So we're sending the updates on loopback 0, we're sending the updates out serial 00, and now RIPng, our packet is waiting, received my own response, because again, we see this message because the loopback 0 interface is our own interface. So let's come over to router 2 and let's do this. Let's go into global config and say router, whoops, sorry about that. We'll say IPv6, router RIP, and over here we're CCIE. And again, I do the question mark. We have the poison reverse option, and that's it. So it's all or nothing. So here is what's going to change. Remember, right now, we're receiving these updates. That's our send. Where's our receive? Yeah, received, and we see we're getting 10, 11, 12, 3, and 2 from router 2. Let's take a look at what happens when I turn on poison reverse. So the first thing we want to look at is I'm going to say do show IPv6 RIP. And let's confirm, and we did create some additional RIP processes here, but we're interested in the CCIE process. That's the one that's actually in use. And now let's take a look here. Split horizon is on, poison reverse is on. So they're both on. So let me come back over to router 1 and let's take a look and see, is anything different? So here's our response. Give it a second here. So here's our response, and let me go ahead and say you all. So we're going to kill the debugging here for a second. And here we are. So we're interested in what's happening right in here. So now, what is different now that we have poison reverse on? So we get a response from router 2, FE80::2, and what do we see? Well, we see that this specific route here, the 2001 DB8 Cafe 1::/64, now has a metric which is set to what? It's set to 16. And what does 16 equal in RIP, in all implementations of RIP? It represents infinity, right? Which means that that route is completely unreachable. And so if we look over here, where is that route? Well, it's this loopback route here. Now, remember, we've turned poison reverse. So poison reverse is on at router 2. So what router 2 is going to do now, and this is poison reverse, is he's not going to suppress sending this advertisement which he is learning from router 1. And remember, split horizon says if router 1 sends the update for this loopback address into that, and router 2 learns it through this interface, split horizon says that when I advertise back, I'm just simply going to omit this route, right? That's split horizon. When we turn poison reverse on, what poison reverse says is I am going to poison with a metric of 16 in the reverse direction the route that I learned in through this interface, which I am going to go ahead and send it back, but I'm sending it back as poisoned. And poisoned in the sense that the metric is set to infinity and it's in the reverse direction. And so this is very different from split horizon. So now let me go ahead and let's kick split horizon on here. Let me clear the screen. Let's kick split horizon on router 1. So we'll go into global config. I'll say IPv6, whoops, router RIP. Oops, sorry about that. And we need the process name, CCNP. And I'm going to say poison reverse. Now let's keep our debug on as well. And let's turn the debug on and let's see what we see now. So now we have poison reverse on both sides. And we should see here shortly, and there we go. So we've got updates going out, and now we're sending updates out. And in fact, let me go ahead and stop it right there because that's actually the output that we're looking for. I'll go ahead and highlight what we're very interested in. So again, take a look at what router 1 is now sending as an update, right? Sending an update out at serial 000 interface for the RIPng process CCNP. And take a look at this, right? This is all being done inside of a VRF, the default VRF. Remember before, what did the update that router 1 sent look like before? Well, absolutely right. It was, remember, it was only 2 routes. It was the loopback address and the transit network. That was what router 1 was sending to router 2. Because remember, before we were running split horizon. And split horizon says that for routes that you learn from a neighbor in a coming through a specific interface, that you do not send those routes back, right? I don't re-advertise those routes back because it doesn't make sense. If I'm learning them from that interface, I'm not going to turn around and tell router 2, hey, here are these routes I just learned from you. And a good analogy, I was talking with a colleague of mine, a good analogy would be that router 2 says, hi, I'm router 2, and then router 1 says, you're router 2. So router 2 is going to look at router 1 and be like, why are you telling me I'm router 2? I know I'm router 2. And it's the same thing here. Router 2 says, hey, here are these advertisements, and I don't know if we got the receive. Yeah, here's our receive response. So router 2 says, hey, here's an advertisement for these 4 routes. With split horizon, it doesn't make sense for router 1 to say, yeah, hey, here's an advertisement for these 4 routes I just learned from you. Because router 2 is going to scratch his head and say, why are you telling me that? Because I just told you that these are the routes from me, right? And so that's split horizon. Look at poison reverse. What does it do? It poisons the advertisement for the routes that it did learn on that interface, but what is it doing? It is sending those back. So it is poisoning them in the reverse direction. And this is the difference, and this also proves when you enable poison reverse, is split horizon in effect? It's not, because if split horizon was in effect, this advertisement that router 1 is sending, and here we know it's router 1 because there's the source address, right? This advertisement router 1 is sending, it would be sending it back with only these 2 routes. We saw that earlier, right? And so this also proves that when you turn on poison reverse, it is overriding split horizon. Split horizon is no longer in play here. And so this, and we'll talk about when this comes into play or why you would turn this on, why this is preferable here in a couple seconds. But I also want to come up here and take a look here. So take a look at, it says RIPng sending an update, and it's being sourced from this link local address. Now this is the link local address, and you can see it's EUI 64, right? There's our FFFE, and we have our loopback 0 address here. So the update is coming from loopback 0, but take a look, right? And this is always interesting output here. I love the debugs. Look at our metrics. The metric is 2. So if the loopback address is sending out an update, right? And what's its destination, right? It's going to the RIPng multicast IPv6 address, FF02::9. Why is the metric 2? Because again, here you're probably asking yourselves, well, wait a second, Travis, you just told me that when poison reverse is in effect, it's going to poison the advertisements, right, that are going out in the reverse direction on the interface on which they were learned. And I'm going to stand by that statement. And here's what's happening, right? Did we learn these 4 routes inbound from router 2? We did not, on the loopback interface. So in other words, did the router 2 updates come in the loopback interface? They did not. What interface did they show up on? They showed up on the serial 000. And then what happened is an update got sent out to the loopback interface, right? And that's a terrible arrow there. It got sent out to the loopback interface. So from the loopback interface's perspective, he did not learn these routes from the serial 000 interface from router 2. He learned them from router 1, which counts itself in the metric, and then the loopback address is accounted, and then the next hop is accounted for. And so the metric will be 2, because remember, poison reverse says that if I learn a route from a neighbor through an incoming interface, I'm not going to do what split horizon does, which is suppress it and not send it back this direction. I'm going to send it back in the reverse direction, and I'm going to poison it, and it being the route. And I poison it by simply setting, we'll say poison. I'm simply poison it by setting the metric to 16. So now let's transition the conversation to, well, why? Why would I choose poison reverse over split horizon? And then the question is, well, why does Cisco only implement by default split horizon instead of poison reverse? So the reason is this, and so let me go ahead and draw. If I had a serial link here, and let's say that this is all RIPng, right? So we're running RIPng between all of these guys. And this is a great example. So we've got this loop back here, and this loop back is being advertised this direction and this direction. Now, when that loopback is learned on router 1, let's say we're only doing split horizon. When router 1 gets that update in, he's going to ship that entire update, including that loopback address, right, over to router 3. When router 3 gets that advertisement in, he's going to send his whole routing table every 30 seconds over here to router 1. And they're going to be including that loopback address, right? So I'll say loopback 0 for router 2. So 1 and 3 are going to be telling each other, hey, I know how to get to this guy, right? Because again, remember, distance vector routing is like, it's think of it as like routing by rumor, right? And that's you hear that sometimes, routing by rumor, where when router 1 tells router 3, hey, I know how to get to this this network, router 3 just has to trust that router 1 is giving him valid information, right? Similar to a rumor, okay? Now, what happens when this goes away and we're only doing split horizon? No poison reverse. So this route gets removed. Remember, it sits in the routing table for 3 minutes. So if router 1 tells router 3, after this route has gone away, router 1 still thinks he knows how to get to that route. He's going to tell router 3, hey, you can get there, just come through me. And maybe router 3 is telling router 1 the same thing. Hey, I know how to get to this route. You can get to that route coming to me. And so you could end up with a loop because both of these guys think that they are the best way to get there. However, there is no way to get there because ultimately the route would be withdrawn. And at that point, if 1 is telling 3, yep, I still know how to get there, it's not going to work, right? And then you sort of create the loop. So with poison reverse, what are we talking about? And let me go ahead, and I apologize here. Let me pick a, we'll go blue. So now we're going to talk about poison reverse. So, and this is what we're looking at right over here is the poison reverse scenario. So poison reverse says, from the get-go, we're not going to waste any time like Split Horizon does suppressing the advertisement back out the same interface we're learning things on. We're doing it right away. So this loopback interface here, it's going to be advertised here, and it's going to be advertised here. And what's going to happen is that all of the router, I should say, not all of them. So router 3 and router 1 are simply going to advertise that back like we see right here with an infinite metric, right? Poisoned to 16. And so at that point, all of the routers already know, and we just lost everything there. Let me clear the screen here. Whoops, let me clear the screen out real quick. So we already know that it's being poisoned when it's being sent back, right? And same thing here, if I'm learning about it across this route, it's gonna be poisoned. And so basically poison reverse says, don't suppress the advertisement back out the same interface on which I'm learning those routes. It simply says suppress it. So any routes I learn inbound on this interface from router 2, in my updates back to router 2, I'm sending those updates for these routes here, not suppressing them like Split Horizon, but poison reverse says, yep, go ahead, send it back with an infinite metric of 16. Right? And it's the same thing. If router 3 is advertising routes, router 1 is going to send them back with an infinite metric of 16. And so let's take one last look here, and let me pull that back, and let's take one final look here at show IPv6 RIP. And here you can see Split Horizon is on and poison reverse is on. And does anything change if I say go to global config IPv6 router RIP, and here we are CCNP, and if I say no Split Horizon, so do show IPv6 RIP, so now I've turned off Split Horizon, right? So let's do our debug. Do debug IPv6 RIP. And we'll see our updates come in, and let's see, does this change anything? And we can actually stop right there if I can get it quick enough. And we take a look here, our update that's going out to router 2, did anything change? Nothing changed, right? We still poison the routes because poison reverse takes precedence over Split Horizon. In fact, when you turn poison reverse on, like we just saw here, you can go ahead and turn Split Horizon off. Because even if Split Horizon is on, what takes precedence? You've got it. Poison reverse. Okay, so hopefully this has clarified the similarities and the differences and the reason why you would choose one over the other. And again, we took a look at a number of things. We saw what the RFC said should be implemented. We saw that, at least right now, with the version of code I'm running, which is 15.3, I haven't tested this on 15.4 or 15.5, so maybe it's in there. But with 15.3 code, there's no way for me to adjust the poison reverse or the Split Horizon on a per interface basis, right? Right now, it's all or nothing. And we proved that. There's no way to get it to turn on just the interface. When we do it, it's getting turned on all interfaces. And we also saw that, again, poison reverse will take precedence over Split Horizon, right? But what they both kind of achieve the same thing, right? Which is loop prevention, except they do it in different fashions. And again, your use case may be different. One thing to think about is if you are on a very low speed link, maybe you've got a 56K or 128K, fractional T1, and you're pushing across updates. Remember, take a look at the size of this update, right? This update is going to include back to router 2 everything I've learned from router 2 when I'm doing poison reverse. If I'm on a really small link, maybe split horizon is the better approach. Because if I'm sending, maybe there's 200 routes, right, that need to be pushed back via poison reverse with a metric of 16, and it's going across a 56K link. Do I really want to do that, or do I want to say, hey, okay, well, I'll go ahead and do split horizon and make other architectural changes maybe to facilitate that? So again, it comes down to your use case. All right, so this wraps up this compare and contrast session here on split horizon and poison reverse, specifically with the Cisco implementation and RIPng. All right, well, thanks for watching, and I will see you guys on Monday evening. Enjoy the rest of your weekend.